Hi everyone, thank you very much for coming to my talk. I'm rounding out the trio of Flutter talks today, so I'll be talking about something that's very different, say, from what Brett did, where Flutter is an awesome tool to do live coding demos. I'm not going to be doing that. Instead, I'll be talking about some more run-of-the-mill things to do with getting your app ready for production and all the things that entails. Because once you've done some intros and some proof of concepts, similar to what Susie talked about previously, there's a lot of issues that you need to face in terms of getting a production ready app, especially if it's going to be a commercial app or a commercial project that's free in the various app and play stores. So I'll be covering a wide variety of topics to hopefully give you a leg up if you're going to be working on a Flutter app in the future. If not, don't fret. A lot of these are actually things that are common to all mobile app development projects. So hopefully, even if you decide that Flutter's not right for your next project, or you don't get a chance to use Flutter straight away, these will still be handy for your Android or iOS or web development projects. So just a very quick intro, because I'm hoping most people by now know what Flutter is. So this is essentially a nice quick elevator pitch from Google of what they think Flutter is and what it's good for. Now, the first thing I'd like to talk about, which isn't quite to do with things about getting your app production ready, but it's something that's a bit dear to my heart, so I had to include it, and it's developer user experience. Because I've been doing software development longer than I care to think about, and for me, it's important to have a good developer experience. And basically, most of my software engineering career has been putting up with very bad developer experiences. And I think that's a very common experience for a lot of people. Now, what really impressed me was, I think Flutter is the first platform that I personally have worked on where they care very deeply about the developer experience. And in fact, they care so much that they have a dedicated, very visible person in Chris Sells, who's the PM of developer experience. He's not the PM of Flutter, he's the PM for developer experience. And for me, that's a really good sign that they're concerned about how good an experience developers have in using Flutter to build apps. Now, in case you think, oh yes, Max is the organizer or co-organizer of Flutter, he's like all a fanboy of Flutter. Like Jake Wharton, who some of you may know from the Android community, is not the biggest fan of Flutter. But I did manage to see this tweet from him. I think it was actually partly in response to something I'd replied back to him about, where he did say that, all right, there are other things that he's not happy about with Flutter. You can see part of that there, but the developer experience is something he says is a great thing in Flutter. So, taking the great developer experience, the first topic I'd like to talk about is the experience of starting not from scratch, starting with a brownfields project, not a greenfields project, where you've already got code, most likely for Android and iOS. Maybe just one of the two platforms, but most likely you're starting from a project that has legacy, it's got both. Now, Google has a technique that they recommend for this. It's called add to app, where basically they recommend that you take a slice of Flutter, like one of the talks recently called it a side of Flutter to Android, and you can add it to your Android and iOS apps and just dip your toe into the water. For me, I wanted to take a different approach. So Max's approach, I coined FLAP, which is basically Flutter app porting, which is essentially the inverse of that. And what I did was I took the fact that when you do a Flutter create, essentially you get an Android and an iOS app project within your Flutter code base. So starting from that, what I did was then took the existing code bases and carefully copied them into those Android and iOS folders. So essentially I took the existing apps and put them inside the Flutter app. The reason I did this was I wanted to get as close to the endpoint as I could from the beginning, and for me the endpoint was a Flutter app, not an Android and an iOS app that happened to have a little bit of Flutter. So this, for me, was the best approach. So it was a little bit of pain up front, but honestly, it was really only a few days of work to go from nothing to having both native apps running within essentially the Flutter app container. And I've been doing this project now for around 6 months, and I've so far been very happy with the results of taking this approach versus the opposite, which I do note, like, of course it's not the only reason, but a lot of the negative press that React Native got over last year, I have noted came from teams, big and small, that took the other approach of just adding a little bit of React Native to their existing native apps, and then they had, not necessarily because of that, but a lot of, I think, the troubles that they had stemmed in part from taking that approach versus going whole hog, as it were. Of course, there are risks, I won't deny that, but I personally have found this approach to work very well for my use case. Now, another thing I found very useful, which unfortunately I didn't know about at the beginning, was a package called Storyboard, which you can get just from PubDev, as usual. And what it lets you do is give you a little bit of a framework for putting up your app screens in isolation. Essentially, it gives you like a little container for proof of concepts of each screen. Now, what this encourages you to do is to think about your screens in an isolated, contained way. But the really good thing is, and this is comes from the fact that it was actually inspired by a tool in the React Angular world called Storybook. It kind of lets you create a palette of all your screens and widgets, because as you might realize soon after starting Flutter, everything's about widgets, and widgets composed with other widgets. So having like essentially a palette of which is standalone from all your data and all the other services and things you might have in your app, which lets you easily create each new widget, each new screen, and see how it looks and deal with it in isolation, is really helpful. And especially when your app is in the halfway point, as it were, where you need to quickly refer to lots of different screens without having all the infrastructure in place and all the scaffolding that your real app has, I found extremely useful. Moving on to everyone's favourite subject with Flutter and reactive systems in general is state management. Okay, like I said, a close cousin of Flutter is React, and so some people, when they've come to Flutter, have brought, for instance, Redux with them and found it very useful and helpful. No problems. But for me, I have found Google's recommendations. Like previously, they didn't have anything recommended. As of last I/O, they said, we recommend provider if you don't have a good reason to choose something else. And you might have a good reason. But for me, the provider package, that's the starting point, and that's been my end point. I've been happy with that. I've used the blocks model, the blocks pattern, if you like, and moved on. But I should say that coming from the Android world, being an Android developer, I view block maybe not the way the people who've written it intended. So for me, I see block and read view model. And for the most part, that's worked quite well. So for those of you who are coming, say, from the Android world, if you mostly, like if you squint and think of view model when you see the word block, that gets you a fair way there. The essential thing is keep your logic, and especially your business logic, out of your widgets. Like it's cool for demos, it's cool to quickly get something up and running. It is not cool, even in Flutter's dynamic world, to do that in a large app. You will definitely run into hassles very quickly if you take that approach in the long term. And for me, block is pragmatic in that, like, it's supposed to be all streams. I don't do all streams. I have callbacks, I have values in my blocks. Like I said, for me, a block is pretty much view model in my Flutter app. Like, it doesn't mean you have to do exactly that, but this is the approach I found very useful. And if you're doing clean architecture, like fans of Dr. Bob, Uncle Bob, I recommend separating your service layer out of the blocks as well. Like it's quite tempting to put it in your blocks, but really if you treat them as view models, keep the service layer outside. I found that as the app's grown, that's really helped to keep things nice. A little bit more about state management, and this comes back to what I talked about storyboarding. It's really useful, I found, not to over-rely on Provider. Provider is an awesome package. Like I said, I love it, I've found it, I'm sticky with it, but I have found that using Provider and essentially the leaf nodes, the very kind of bottom widgets, was rather problematic, especially when I came to wanting to storyboard them and to test them in isolation, because then I have to mock my blocks, or I have to basically create versions of my blocks where I don't want to, just to have them around in the tree above the widgets that I'm storyboarding or testing. So my preference has actually been to isolate those kind of presentational dumb widgets, if you like, that are towards the very bottom, the very leaves of your widget tree, and just pass in the things they need. Because I have to admit, when I actually started doing this, what I found is mostly what they want is a value, they want a stream, they want a callback. Sometimes all three, but usually just like one or two things is really all they need. They don't need all the stuff that the block that's above them in the tree provides, because there's a whole bunch of other widgets further up the tree that are also using bits and pieces, or siblings that are using other bits and pieces of that block, because I haven't gone the route of blocks like down every level. I've had only basically half a dozen or so top level blocks that I've used throughout the whole app. So basically, again, this is just a thing that's worked for me, but I recommend it because it's worked really well as the app's grown from small code base to now, I think I'm up to about 11,000 lines as per the C-Lock app. So that, it's not huge, but the app's getting reasonably big now, and this approach has scaled quite well. Again, it's nothing new under the sun. I completely admit that this is really something that's, again, an approach that seems to be well known in the React world, and like the best article I found talking about it was that one by Dan Abramov, who's like kind of like the React Redux guy. So moving on to even, I guess, more mundane things, how to lay out your files. What's the project structure? Because I'm an Android developer. I've been an Android developer for a long time. Android pretty much gives us a good framework for where to put files, where to put directories, at least in the top level. Okay, people disagree a little bit about how to structure your source code when it comes to like Java and then Kotlin, like what your packages should be, but otherwise things are pretty clear. Flutter, not so much. Flutter's pretty much, at the moment, yeah, do what is good for you. So I'll just give you what's been good for me, and you can take it or leave it, and maybe at least use it as a starting point to decide why you don't want to do it this way. So at the top level, I do lib, assets, test, and docs. Hopefully that's pretty self-explanatory. The lib directory is like all the source code, except for the test directory, which has the test source code, the assets, and docs is just where I put all my text markdown files, documented stuff. Inside lib, this might look a bit familiar to people coming from Android, perhaps not so much for iOS or web people. So I did use my background to sort of divide things up. So blocks, so that's basically where my view models folding or package would be in Kotlin. Then I've got top level for screens to have all the widgets that represent a whole screen. Services for the services layer. Style would be all the R files that you'd have, all the code generated R files that you'd have in an Android project. I do a similar sort of thing by hand. Types is essentially it's kind of shared types, which is a bit of a fudge breaking. Sometimes the encapsulation between the services and the blocks layer that Uncle Bob would probably not approve of, but that's the way I did it in a pragmatic way. And widgets are widgets that are reused across more than one screen. And and plugins is, I'll get to in a second what I've done with that. Inside the assets, I just basically started having everything in one folder. That got really messy really quick. So things got divided up into localization files, fonts, data for just bits of like preloaded data that the app needs, videos for videos and so forth, icons for icons. That's all pretty straightforward. Native integration. That's what I was talking about with that plugin folder. I've taken the route of not being bothered to create my own actual plugin modules when it came to the integration of the app needs, because the integration is for very specific native bits that the existing app code base had, which are extremely unlikely to ever be reused, or in fact they're quite proprietary, so they're not likely to ever be even published in the near future. So all I did was I just, of course, still used the plugin infrastructure, But because I was doing it myself without creating real plugins, instead of relying on Flutter's tooling to do it for me, I needed to just simply add that line of code down the bottom for every plugin class that I had. So in this case, you're seeing a little bit preview of a few slides further down, which is a plugin to use OpenGL. I also had plugins because, I should have said that the app I'm working on is a bit unusual in that it's a companion app to a Bluetooth device. So there's a lot of native platform code that the Flutter code needs to talk to, especially for Bluetooth comms and services. So there's a Bluetooth plugin, there's another one for on Android for broadcast receivers. You can imagine getting notifications from the system for all kinds of things that we need. Similar things on iOS. Took a malfunction. Deeper integration. So it turned out that the existing apps needed or used not just native OpenGL code, they had C++ OpenGL code that they were using, and they were not at all keen to have any of that rewritten. And to be honest, neither was I. So I was a bit worried because I knew the Flutter plugin system when I first started Flutter was all about async comms, and that's not exactly high performance. That definitely does not sound like I kind of think that it's going to do OpenGL like 30, 50 frames, 60 frames a second animations that we needed. Luckily, I discovered that someone had already paved the way for me, and that it was actually possible not just to do Dart to native Java, Kotlin, Swift, Objective-C integration, but also down to native C++ via, for instance, JNI on Android, and to do so in a performant manner, because thankfully that's exactly what video playback, especially camera video preview, requires. So because those things needed it, it was already doable, it just wasn't particularly documented until I found this fantastic article by, so I had to give him credit, by, I hope I get his name right, Jermaine Saprikin, documenting how to do a very simple proof of concept, which was enough to get me going. And I'm here to tell you that it is possible. It's actually even possible to have an OpenGL texture that's animating at 60 frames a second. That Dart then animates, so say a hero animation, although we've ended up not using that. But it is doable, and in release mode, it's pretty performant. So you can get actually very deep integration, even one layer better, if you like, or more performant than the plugins. Though it has to be something that the Flutter framework already supports. In this case, they had to already for native video and OpenGL. So this OpenGL system was already available. Now, this is another one of my pet topics. Things always go wrong, and to me, as a developer, I'm pretty sure I spend more time dealing with things that have gone wrong than just writing new code from scratch. It's usually, most of the time, goes into debugging or figuring out what the heck has gone wrong or broken. So I wanted to cover a few topics that deal with aspects of that. For instance, logging. In Flutter, I think it's much more useful than other places like, say, native Android development, where it's really considered a poor man's debugger, because you have to recompile to add a print statement here or a log statement there. Of course you don't in Flutter. You've got hot reload, and if worse comes to worse, hot restart. So I found logging was way more valuable in Flutter. The only problem is you've got choices, yet more choices. I was a bit overwhelmed after I moved on past the print statement, which is just like the most common example that you see, because there's two different packages from our friends at Google. There's also at least 3 different third-party logging packages. There's been one attempt to kind of homogenize things that was done by a Flutter Google team member that seems to have been paused or abandoned, I'm not sure, but anyway, it's a bit too much choice than I was really wanting. So currently I'm using a third-party package. Luckily I've wrapped it in my own API, so I'm intending to switch to Dart Developer, which I think is really the best way to go right now, because it has nice integration with the Flutter's DevTools. So that's currently my best recommendation for doing that. Oh, and I have to admit that for pragmatic purposes, I do recommend though print is like just too easy to use if you need to just add a few print statements here and there. So I will be honest, I still use it quite a bit. But for any logging, especially that you're leaving past your current Git commit, I'd recommend Dart Developer would be the way to go. But wrap it in your own API for goodness sakes, because then if what I tell you now is no longer true 2 months from now, Flutter's moving still very quickly, you'll be happy that all you have to do is switch out your implementation and not do a search and replace across like several hundred files. Oh yeah, and there are some still rough edges, like for instance, I keep meaning to raise this, I think as an issue, or I think there is already an issue for VS Code that you can't filter your logging based on levels like you can in Android Studio. This is more because I've chosen to use VS Code over Android Studio. I think Android Studio actually works a bit better here. Debugging. Nice thing is, or the thing that I'd like everyone to know, in case they don't already know, is that you need to, at least in VS Code, and I know VS Code is quite popular, so I'm not the only one here, you need to go into the settings and turn on the Dart Debug External Libraries option if you want to be able to debug into an external library and not sit there scratching your head for an hour or so like I did, wondering why I couldn't do that. I really should have Googled for it after the first 10 minutes, but I didn't. And then there's also the other option which lets you debug into the SDK libraries, which, okay, like they're really good quality, but sometimes you do need to get in there to see what's happening. So that I have found not often, but very useful on occasion. Likewise, be aware that there's a little tick box for catching all exceptions and also uncaught exceptions. Find that very handy, especially when you're just in the middle of doing lots of things, and sometimes you want to be able to not just have a log that the error went off somewhere, but actually break at that exception and not just have it bubble up to the top. I was going to talk about this, and I did at a previous talk. It's probably not so much important now because, yeah, the package that I was going to talk about, which lets you log HTTP traffic inside Dart's library, because guess what? Dart does not use your native platform's HTTP implementation. They've got their very own one. I found this package very useful, and then I found that it looks like it's not going to be maintained anymore. It looks like it's been stopped, paused, whatever. But you can still make use of it, and the good thing is it's very easy to use, and in opposition to several libraries which provide in-app logging, I much prefer to have it in my tooling rather than on the phone. Like, I think the in-app tooling is probably good for testers, but for me, I prefer it in my IDE, not on the device. So I'd still recommend using it if you don't have any other tools. The other tools being Charles, which I suspect a lot of people, oh, I can see shaking of heads, yes, yes. It's good and bad, but like I found Charles to be useful on occasion. Just be aware again, if you just fire at Charles, you'll be amazed that nothing appears because, hey presto, Dart's got its own HTTP library, so you need to configure it to use Charles. You can't just do the normal settings like, for instance, you would in an Android device or an emulator. Okay, so sometimes even the awesome, most best first-party plugins might not have the feature you need or might have a bug. So you can do what I did and hassle your local DevRel person about it, but sometimes the bugs or the missing features are in a third-party package where the maintainer might be MIA or might respond to your issue or pull request like 2 months later, if you're lucky. So sometimes you need to fork. Luckily, and this is what I really like about Dart, is you don't have to go off to a third-party website to build your package for you off your Git repo branch that you've fixed the bug or added the one little feature that you needed. You can, I wonder how many people do know that you can put up your hands if you knew that you can actually just put in a Git URL and branch reference in PubSpec to point to a package that you want to use. Oh, cool. So hopefully I've given you another little useful piece of information. I found this supremely useful. Basically, anything that you're using, click fork on GitHub, because I almost guarantee you it's on GitHub rather than GitLab or Bitbucket. I'm sorry, but that's the way. Make your change, put your GitHub repo URL in there in the branch that you've done. That's it. You've now got your own version of that package. You might not want to do that in the long term. Submit a PR, please. Bug the maintainer to merge your PR. But in the short term, or especially like on the day where you actually need to get a demo working for your boss, fantastic. Crashlytics, yep, that says it all. I'm sorry, I know it's a Google product. I just was not happy. I know there are some Firebase fans. It just was painful. It didn't work. And I've used Crashlytics on a number of Android apps in the past, but I'm sorry, it just was not a nice experience for Flutter. I discovered Sentry, which is actually in the Flutter docs and seems to be the Flutter team's recommended way of doing crash monitoring. Worked brilliantly, loved it. First party package, as in from Google people. There's a PR that I thought would be in by now, but it's still waiting to be merged, that adds context support, so you know that like it was an Android Nexus 5X that did that bug report rather than just like, here's a bug report. So that's essentially calls context. So really need that for production. Luckily, I'm hoping it's going to be merged any day now. So, and that's actually my last slide. So I'm happy to take questions in the last minute or two that we have. Thank you.